Start it now. So today's program is based on binary search tree, pre-order, post-order, and in-order traverser. You all know that binary search tree is a binary tree data structure with a special feature that whenever you insert nodes in binary search tree, smaller values are kept towards left and bigger values are kept towards right. Now here in this program, first of all, we have created a node. So we have public class node T. So here we have created a node in the binary search tree. This code public int value represents that the value is present in the node, and then public node left. So we have created a reference to the left subtree, and public node right. Here we have created a reference to the right subtree. You can see over here comments are also given accordingly. So when you will study it later on, it will be helpful to you to identify what this particular code is doing. Now next is public node int value. Now we have a function called node, and the argument is value, which is of integer type, and we are pointing to value. Now value will be inserted later on. We will see. It's quite a big program where we are creating a tree, binary search tree, and then we will perform all three types of traversal. So next is we are creating a class called binary search tree. This class represents the BST. Now the reference for the root is created. So we have public node and root. So whenever you have to create reference, you have to use this keyword node. In previous slide, whenever you are creating a reference, you have to use keyword node. Now we are creating a function to insert values inside binary search tree, and the name of that function is binary search tree insert. This is the name. You can use any name you want, and we are passing values inside it which are of type integer. So we will insert some integer values in that tree. Now we have created a reference variable, that is node. Now we will find out that if root is equals to null. If root is equals to null, that means so far the tree is null. So far no node has been inserted in that tree. So if root is equals to null, what will happen? Root is equals to node. That means suppose if values are given to you like this, 3, 10, yes, no tree, 10, 15. So initially we will find out whether the root is null or not. If suppose root is null, what we are doing? We are starting from leftmost node. So this node will be treated as a root node, isn't it? This is a root node? Yes. So this will become root node. This will become root node. So that's why we have root is equals to node if root is equals to null. Now what we are doing, we are calling this method. This is a method, insert rec root comma node. Now here you will see that we are passing two arguments. One argument is root and another argument is node. Why we are passing two arguments? Can you tell me? because it's binary. Next value, we have root. Okay, see, already we have inserted root. Okay, this is our root value. Okay, 3. Now what happens? Next comes this node, 10. So every time you have to make comparison. So when this node comes, you have to compare it with root node. So one is root and second one is node, because root is already there. Yes, and now next value comes. That is node value, and we have to compare those values. So you can see over here in this code, what we are doing, we have implemented this insert REC function. The insert REC function that is being called here is defined here. This is known as function definition. This is definition. Yes, yes. Now we have to find out whether we have to put that value towards left or right. Yes, this is definition. So here we will compare the root value with the node value. So if the root value is greater than the node value, okay, then what we will do, we will perform next comparison whether root is equals to null or not. If it is not, now you know that the value which is placed towards left is smaller than the root, isn't it? Yes? Yes. That means the root value is greater than the node value, which is placed towards left. So here, if the root value is greater than the node value, then it will be placed towards left. If node value, root, see, this is our root, 3. Okay? 10. 10 is bigger than 3. So it will be placed towards right. Okay? It will be placed towards right. Now if suppose here we have 2. Then 2 will come towards left. Now you can see that this root value is greater than this value. Root value is always greater than the value of node which is placed towards left. So here, if the root value is greater than the node value, then that node is placed towards left. Okay? And if it is not, that means the root value is less than the node value, then it will be placed towards right. Is it clear? Good. Now here in this code, we are finding out which node has minimum value. Which node has minimum value? So what will happen? Each and every node will be compared. Each and every node will be compared, and then by do all the tree. What do you mean by this, Ms. Fatima? Mm-hmm. See, when you will see your tree, there will be a root node, and all those values which are smaller than the root node will be placed towards left subtree, will form a left subtree. And all those values which are greater than the root node will form right subtree. Okay. Now we know that left subtree has a small values. But what we are doing, we want to find out the smallest node out of that. So this code will find out the smallest value, the minimum value in the binary search tree. And this code will find out the maximum value in the binary search tree. So maximum value, you can find out in right subtree. But you have to make comparison in order to find. That's why here you have right, current node dot right, because we know that only right subtree have the highest values, but we have to find which one is maximum. Similarly, we are just searching the left subtree. So that's why it is being said that in case of binary search tree, additions, deletions, sorting, searching operation is done very fast. Is it clear? Good. Now, you know that we have three types of traversals: in order, pre-order, and post-order. In order traversal, the left subtree of the given node is visited first. Then the value at the given node is printed, and then the right subtree of the given node is visited. So this process is applied recursively in all the nodes in the tree until either the left subtree is empty or the right subtree is empty. So this code, yes, I can repeat. This code will print the content of tree in order way. In order means that first of all you will visit left subtree, then you will visit root node, and then you will visit right subtree, isn't it? This is in order. Left subtree, then root node, and then right subtree. So in this traversal, the left subtree of the given node is visited first. Okay. And then the value at the given node is printed. That means the root node is printed. And then the right subtree of the given node is visited. So this process is applied recursively until and unless all the nodes in the tree, which is either the left subtree is empty or the right subtree is empty. So you have to apply this rule in order to find out in order traversal nodes. So this is thing we have done. We have created a helper method to recursively print the contents in order way. This one. Similarly, if we want to print the contents in pre-order way, what we have in pre-order traversal? What happens in pre-order? Which one is visited first? Yes, anyone? Are you with me? left. Okay, I will repeat it again. In case of pre-order, first of all, you have to visit root node, root. Okay, and then you have to visit left subtree. First of all, root, then left subtree, and after that, right subtree. So in this traversal, the value at the given node is printed first, and then the left subtree of the given node is visited, and then the right subtree of the given node is visited. So this process is applied recursively, all the nodes in the tree, until either the left subtree is empty or the right subtree is empty. So here we have created a recursive method for that. And then finally, we have to print the contents of the tree in a post-order way. Now, what do you mean by post-order? Yes, what do you mean by post-order? Post order, RS, then RLS. RS, then R, then LS. That means right subtree, then root, then left subtree. Isn't it? Then what is there in... No. See, in case of in order, what we have root in middle, okay? We have left subtree, then root in middle, and then right subtree. Okay, so this happens in case of in order traversal. First of all, left subtree, then root, and then right subtree. Now, when we are talking about post order, first of all, left subtree is visited. First of all, left subtree. And after that, we have right subtree. And root is visited in the last, because this is post order, post. So, root is visited in the last. So, in this traversal, the left subtree of the given node is traversed first, then the right subtree of the given node is traversed, and then the value at the given node is printed. This process is applied recursively, all the nodes in the tree, until either the left subtree is empty or the right subtree is empty. So we have created a helper method to recursively print the contents in post order way. And then we have created a class called binary search tree demo. Inside this class we have main method. So you will, when you will save your program, you will save it by this name, because main method is inside this class. Then we have created BST, which is a reference variable for the binary search tree, and this reference variable will be used to insert these elements 40, 25, 7, 8, 10. So these are the node values which are of type integer. Now how many values are inserted? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and 11. So 11 nodes are inserted, and then we will get in order traversal, pre-order traversal, post-order traversal, and the minimum and the maximum value in that search tree. Now can you tell me what will be when you will insert these values? When you will insert these values, how our binary search tree will be like? First of all, which root node you have? Which one will be your root node? Good. So first of all, you have 40, okay? First of all, you have 40. This is our root node. And then next is 25. So 25 will be towards left, yes. So here you will have 25. Yes, good. And after that, you have 78. So 78 will be towards right, yes, good. So here you have 78. Yes, good, right. 78. Now you have 10. So where will be 10? Okay, 10 to the left and below 25. So it will be like this. 10 and then 3. So 3 will be where? Okay, towards left of 10. Good. And then you have 17. So 17 will be right of 10. Yes, yes, yes. So here you have 17. Good. So here we have 17. Now next is 32. So where we have 32? Right of 25. Yes. So it will be 32. And then we have 30. Where will be 30? Where we have to place node number 30? Towards right of 32. Towards right? Yes, left, because 30 is less than 32. Yes. So this will be towards left of 32. Yes, towards left. Now next comes 38. So it will be towards yes, right 30. Right of yes, right of 32. So here you have 38. Yes, this will be 38. And then 50. So where we have to place node number 50? Towards left of 78. Very good. Towards left of 78 we have node number 50. And then lastly we have 93. So it will be placed towards right of 78. Yes, absolutely right. So now this is our binary search tree. Binary search tree. Now we have this binary search tree. Now next is what will be the output of this program? So first of all, this program will print in order traversal. In order traversal. And what will be the in order traversal of this binary search tree? Just find it out and tell me. In in-order traversal, you know we have to visit left subtree first, and then root, and then right subtree. So first of all, we have to visit left subtree. So what will be the answer? Yes. First of all, 3, then 10, okay, then 17, after that, and so on. Okay, that's good. Now see, in case of in-order traversal, first of all, we will see left subtree. Yes, from down. So here, this is our left subtree. We will move towards left subtree. Now again in this left subtree, this is root node, this is left subtree, this is right. So we will move towards this. And again, in this subtree, we will move towards left. So first of all, 3 will be printed. Yes, very good. So first of all, 3 is printed, then 10, then 17, then 25, yes. And then we will move towards right. So in this right, this 30, then 32, 38, and then after 38, how? Okay, Miss Michelle, tell me, you have written 25 two times. How come two times 25? 3, 10, 17, and after that you have written 25, okay? And then 30, 32, 38, and again 25. How come? There is some mistake? Yes, you write it twice by mistake. Yes, I understand. Okay. Now let's see what will be the output. Okay. This is the output. In order traversal, then pre-order traversal, then post-order traversal. And then the minimum value, here you have the minimum value and the maximum value of binary search tree. So the minimum value is 3, you can see minimum value is 3 and maximum value is 93. So minimum is 3 and maximum is 93. You have to do it to find out whether this answer is correct or not. If you have any question, you may ask. You have to do this yourself and you have to find it out whether this pre-order traversal and post-order traversal result is correct or not. Okay. Try to run this code on your PC and find it out whether this program gives correct result or not. No questions? Everything is clear? Okay, see you in next face-to-face lecture then. Till then, take care all of you. Assalamu alaikum.